Hey everyone, I'm Nihal. I'm a PhD student at Artmenu. I'm working with my supervisors, Professor Sisi and Dr. Michael at UNSW, and I'll be talking about my PhD topic on space automation for large and complex buildings. Now, I started thinking about how we can use automation in architecture and engineering. I've worked as an architect for 5 years, and I can say that a lot of that time was spent on starting with like getting space plans and working on making them compliant with what the client wants, area considerations, with making them compliant with codes and regulations, and simply there is a lot of repetition, there is a lot of time spent, and there's not much time left for thinking about how the end user is going to use the space. So when I went into like from the industry to research, I found that there is an extensive body of research for like automating space plans since even the 60s, but most of it used a rule-based approach, which is like explicitly defining your design problem and having an idea of what you're going to have in the end. And unfortunately, this is not how design works. Design is an iterative process. You kind of explore more about your problem as you go on. So it's really hard for us to simply write down everything and including what output we are going to get. Here comes another player in the game, which is generative AI or learning-based models that can produce images. Simply think of a black box where you feed it of many past examples of solutions, and that box can detect solution patterns and hopefully apply these solution patterns to new space problems. There are three very popular image generation models used, um, researched for this particular area: generative adversarial networks and graph convolution networks and diffusion models. And if you have used Midjourney or Stable Diffusion, you have probably used diffusion models. And the applications, they range from giving us like rapid feedback instead of working on full-on simulations, what I'm going to work on, which is design guidance, which is using AI to help us get like design options, alternatives, know more about what we are designing, with a focus on circulation and wayfinding. Uh, and another area is having like an inventory of solutions and trying to match it to new problems. Now, when we talk about the design problem we are focusing on, which is wayfinding, it's simply that it's how easy it is for the user to know where they are and move to any other destination very efficiently and in a very straightforward manner. And according to Wiseman, there are four building factors that affect that. First is signage placement, layout configuration, which we will be studying in this research, how the spaces look different from each other, and how further a user can see in a building. And wayfinding is not just about first-time user, but it's also about regular users. For example, it's found that nurses spend like more than 28% of their time just walking around. And another study had asserted that like two-thirds of employees had asserted that it's really hard for them to do the job efficiently if they can't move in an easier manner throughout their office building. And from the design problem, let's talk a bit about what is there, what can computation give us when it comes to learning-based approaches. So for first, how we can communicate with them, with these models. Adversarial networks, for example, you give them an image prompt, usually a building boundary or even a side boundary, and you kind of hope that they detect, like from past examples, how we can solve the space plan. They are very creative. They give us many unexpected outputs, but they are also very hard to train, and getting them to be stable and give us like meaningful results is not that easy. And you have to work with low image resolutions, which is hard when you want like detailed plans. Graph convolution networks, on the other side, they take graphs as an input, usually adjacency graphs, which is good because you get meaningful results that conform to adjacency requirements. But the keyword here is graphs. So sometimes it's hard for complex buildings to just turn them into graph structure and work with that. The newest models are diffusion models. They can take text prompts, they can take image prompts, which increases the ability of architects to control them. But there is still some challenges in communicating parameters such as like position, number of spaces, orientation, etc. The research gaps when it comes to using computation for metrics such as circulation and wayfinding is most of what is out there is simply giving you an index or like an insight of how a plan performs in this area. And this is kind of good, but not good enough because it doesn't really point out to you where the problems are. It doesn't really give you a direction of how you can improve. Um, Also, there is not a lot of research when it comes to like using generative models for simulation. And simulation is hard because it takes a lot of computational power and you need to have refined plans. So there is not much room for change. So my research questions are, first, I need to have a very good understanding of the design problem, like what layout elements that I'm going to be focusing on that really affect wayfinding. And then moving on, how we can integrate those generative models, like how I can communicate my design requirements, how I can then, after getting many alternatives, evaluate them and screen them, and then go back, close the loop, and make changes to them. My aim is simply to identify approaches to refine floor plans of large and complex buildings for having like an optimal user navigation experience using generative models with a focus on how we can communicate to the generative models and them communicating back to us, how to have a flexible approach, making changes fast and easy. Also, consistency, like keeping what works as it is and only making changes where they are needed and having more control on these models. More detailed um, diagram of my research framework. First, I need to define like what are the main requirements that make the floor plan feasible and working with focus on circulation and communicate them through many different approaches, including data set processing, curation, how I'm going to input that data to the generative model and other control methods out there. And then now, what's good about the generative models is they give us a lot of alternatives, maybe even thousands of them. So I have to find a way to screen through these alternatives and get like a sample of the top performing layouts out there. And there are two filtering processes, including rule checking, like knowing that they are compliant with codes and standards and distances are okay, the corridors widths are okay, and also to know how people are going to be, their flow in the plan is going to be like through simulation, and finding out like where the problematic areas are and going back and changing maybe how we are inputting our requirements. So the research implications of what I hope out of this research are, first of all, to have an idea of how can generative models help us generate alternatives for floor plans for large and complex buildings, and also helping architects get expanding their design space and getting multiple solutions, getting feedback on how these layouts perform early on in the design stage, making sure that you get correct, making more correct decisions. And in the end, have buildings that are easier for users to move through and do their jobs. Thank you.
Thank you, Nihal. Yeah, sorry, the first question.
Hello.
Hey.
This is great presentation. You've communicated what you're doing well. What I'm concerned about is being someone who's seen quite a lot of typologies of architecture, is that there are going to be some typologies that aren't affected by this research at all. And there are other typologies that are going to drag this research in completely different directions. And I think it might be best that rather than specifying a building as a large complex building, that you should be picking a very specific type of building to then do the rest of the research. Because there are sections of that research where, like for example, judging the output it's just going to be a nightmare doing that between a stadium versus a train station versus a hospital. And so finding a type of building where that travel distance is critical, it's probably the best one. So that's one thing. And then lay it onto that, and this is always going to be a problem. It's very similar to what Zayed said in the previous presentation, but is yes, you're trying to optimize your building for travel distance, but what are the other things that are going to get in the way of that? So if we pick a hospital, for example, with the nurse travel distance can greatly affect the performance of the hospital. But at the same time, having a radiology department next to I don't know, the pharmacy or whatever, nursery, yeah, it can, that's where your GANs comes in. So I think you always need to take into account that there's going to be other measures, and those measures are going to get in the way of this optimization that you're looking for. So please don't ever forget that. I know you've got that there, but I'm driving the point there that it's going to be super important.
Yes, I think I'm thinking of it more of a filtering process or a layering process. Like there's some stuff that have to be right, absolutely right, and there's some area where you can make changes. So it's kind of like a balance between where to make changes and what to keep. Yeah.
Cool.
Thanks. Thank you so much.
Thank you to David, and then Manish.
Thank you. Yeah, a really good presentation and a really fascinating topic. Wayfinding, I find it really, really interesting, and some of the things you already explained about. And I was just wondering, how do you see the relationship? I know you focused on layouts as sort of one of the things, and I understand that layout is one factor, but I just wonder, how do you see the relationship to other factors? For example, signage. My impression is that signage would be very important, and then so I almost wonder if maybe layout isn't actually the most important factor. I don't know, but I feel like there are quite a few others. And then also, how do you see the relationship to is there maybe a choice modeling aspect to what you're looking at as well? That, how do we make choices based on? I guess one of the things is based on the layout, but I feel like there are a lot of other things that make us make choices, so anyways, I'm curious to hear about that. How do you filter that? I guess also, how do you filter that focus in your research? And yeah.
So you mean like as an architect, there are other stuff we need to focus on besides circulation and wayfinding?
Yeah, I mean, I feel like, layout is probably one of the factors, but sometimes not the only one. Like even in airports or hospitals or so, it might have a bad layout, but if the signage is good, for example, you may be able to have good wayfinding. So I don't, and then probably other factors I haven't thought of, but yeah, I'm just curious.
I think it will make the signage placement just easier because
Right.
through my research, like what I've found is people kind of have like a very refined floor plan and everything is set and everything is coordinated, and they just go like, where are you going to put the signage next? So maybe an interesting idea would be to make these decisions earlier and have them like together. Because also where you place the signage, you need visual accessibility. You need people to be able to see it. So for example, you have very narrow corridors, then not even signage is going to be helpful. So I think they can be taken together. Maybe at some point you can point out these are the absolute best places for putting signage, for example, and you can take them into consideration. So I would definitely think about it.
I think there's a behavior aspect, I feel like, also to it. So that's why I'm about the choice, like what determines our behavior. I wonder, I feel like there are other factors as well. Anyway, something to think about.
Yeah. It's true that when people move in like crowds, there are patterns that are kind of very similar and they can be detected. And I'm very curious about that too.
Thanks for your presentation. Wayfinding is quite a complex issue, and I've been working with wayfinding for stroke rehabilitation over the past few years, and I know how complex it is, and especially came from the people and audience in this room that it requires it requires you to have a clear scope, which building type, and I just again highlight it because when you talk about wayfinding in hospital versus wayfinding in a mall, wayfinding as example. Like even the initial concept of wayfinding came from urban studies, and legibility and imaginability as two factors of wayfinding came from urban down to the indoor space. So the question is, of course, who are the users and why wayfinding is a challenge for them? For example, in stroke rehabilitation, people dealing with a lot of stress and pain as patient, and then wayfinding is another complex issue to deal with, versus in a mall that you're just spending your time to relax and go around. Getting lost is not a problem. It's same as Venice, where many people may enjoy getting lost in the city, versus in a city that in airport, when they wanted to just find the quickest pathway to get into the gate. So the most important thing for you, I think, for this research is establishing a kind of like narrow the scope of which building typology you call complex building, and why wayfinding is important, who are the users, and classifying the users to tie the features and rules of wayfinding back to their needs. That's quite important, because for some users, even the signage can add visual pollution to the whole system. Imagine that you're dealing with so much of pain again, and you're sick of signage itself, to find so many signage around you, and you get lost even by adding signage, more signage. So my recommendation is actually narrowing down your scope to at least a building typology, and start from there by expanding the.
Yes.
Further question, oh, sorry.
Yeah, thank you so much. I will keep it short. I think what most of the discussion, what I was looking at is how would you evaluate it? Because it comes more of a perceptual issue. Then you're not looking for a short distance, you're looking for perception of people to this wayfinding is better than the other wayfinding, for example. And even when there is multiple users, it could be good for certain users, but not for others. So is there any criteria that you're gonna evaluate what is a good solution is at the end?
I think the criteria can be divided into very quantitative aspects, like I need like shortest distance between this place and this place, or how I can put the different spaces near each other or together. But also there are certain layout parameters, like how the geometry is configured. It does have an effect on how people find their way. For example, if you have an atrium, it helps you very much because you have like visual accessibility. You can see like where you are and where everywhere else is, instead of like being in someplace which is very narrow, or you go from a space to another and it's really hard for you to find your way. So what I'm going to try is there is also another aspect, which how people move. For example, if you have a train station and you have like two trains arriving similar times, and people are going to be like flowing in opposite direction, that's also one of the issues, because they kind of become like visual obstruction to each other. So there is a number of qualitative and quantitative metrics that I will need to be defining, and then filtering the outputted layouts from then on. I have some examples like to it, but not like for this.
Coming on.
I kind of feel you've sabotaged your research with your title, because when you said wayfinding, I also thought about signage as the first thing. Well, your research is based on something much bigger and probably more important, which is layout efficiency and adjacency, which is probably much more easy to test as its accuracy and efficiency in the end. Just a comment.
Yeah, thanks for the suggestion. Maybe it's because like wayfinding, some people kind of think of it as like only like finding just your way, but it's more some other research define it, give it a much larger scope. So, but thanks. I think of it.
Yeah, just a second. I'm just wondering how much work have you been able to do and looking at who has been optimizing hospital design, for instance?
Um, I've read a lot of research on agent-based simulation.
Right, because there are consultancies, and there's one guy, Deepak Trash, I'll give you his details. He worked for Intel, and his skills came from organizing chips. But we often forget as architects that there are other contexts which are actually much harder to do with spatial configuration. And I think if you start looking at him and it's years ago that he optimized hospital design, and that's consultancy that they offer. It's, they go to architects and they take the concept and then work out the best possible. And it's all around reducing nurse movements, trying to reduce infection by having as little distance between operating and all the rest of it. So I'll give you those links. But the wayfinding then becomes more important because it's about the human interaction with complex organization rather than optimizing the space itself, because I suspect a lot of the work has been done for quite some while on that. I was quite critical about it because it was an engineering approach. He couldn't care less about what the hospital looked like, it just had to work well. And of course, there's a whole factor on people getting better because the hospital environment is a motivating, optimistic one rather than just a technically efficient arrangement of spaces.
Yeah, I think this is why building type really matters, because the goals are different then. So maybe what works for a hospital is not going to work for some other building type. But that would be great. Giving me thanks. Thank you so much.
Are there any more questions in the audience? Yes, yeah.
Thank you for your presentation. There was a lot of discussion about wayfinding and whatnot so far, but I was personally more curious about the generative AI part. Can you just get some insight on how you plan to use AI in this case and what model and how you plan to kind of go about it?
Well, what is really good about these models is they detect patterns. So first thing is we would be hopeful that they detect like how other architects have solved past building plans. And this is also an exercise we actually do, like when you're starting a project, you kind of look at precedent plans, see like how typically things are arranged, and you can then use it as a starting point and then move on and enhance it and customize it to your own solution. So these models, what they have is they can process that much faster than us, and you can analyze like maybe 10 plans, but they can analyze like millions of plans. Of course, the other issue is we don't have millions of plans, but they can analyze much more than us. And the second thing is also they can many research, what it do is they give it two pairs, like a pair of plans, like a plan with like the rooms and everything, and another one with a simulation result. So it kind of also detects how the plan is like and its performance. So this is pretty much the area that I'm thinking of right now.
Thank you. One last question, please.
Hi, thank you very much for your presentation. I'm interested in the time factor of how you simulate and then the harvesting, not just the layouts, but how they're actually used over time in your precedence research. So as opposed to being a potentially a two-dimensional exercise, that is actually a real-time exercise over time, and rather than the layouts actually speaking the process.
I think one of the biggest issue in simulating like people moving in space is that it takes a lot of time set like the input data and to do the actual simulation. Another issue is that it's pretty continuous, so it's not like one value. It's you kind of have to detect some things and give it like a certain time frame. So it's either we are going to hope to find the best way to decrease the time of the traditional process of just like having a plan and refining it and processing it and putting it in the simulation model. So we will just like test this process and find the best way that generative models can actually interfere. Right now, we know that they can produce many alternatives, which is already great. And then there will be more work on converting, like screening the alternatives first, that they are viable, like they are feasible plans, and then converting them to formats that can be further on, like you can do simulation on, or even use another generative model for predicting the performance rather than doing the actual simulation. I hope that's kind.
Good. Thank you, for your presentation.